4, solving exponential equations. All right, I put the steps that I'm going to take in order to solve an equation for you in red right there. I'm going to do number 1. I'm going to ask you to pause the video and try number 2 on your own to check your understanding. All right, so number 1, I read 243 raised to the negative 3k times 9 raised to the k equals 9 raised to the k minus 3. First thing I notice is that this is an exponential equation because it has bases and exponents. All right, there is a base and an exponent right here. That's one of them. There's a base and an exponent there. That's 2 of them, and there's a base and the exponent on the other side of the equation with equal sign. That's the third one. So that tells me it's exponential. So that's how I'm going to solve this type of equation if I can recognize that it's exponential, and that's what tells me I see bases and exponents. That's the first thing I would see if I saw this type of problem. Now, the second thing I need to consider is all of the variables are in the exponents. In order to solve the variable that exists in the exponent, I need to drop it down to the linear place, or to the base place, all right? In order to do that, I have to cancel out the bases. But again, in order to cancel out bases, I have to do step 1. And step 1 is going to say rewrite each base in a common base format, all right? And this is where we're going to reference the common base chart we filled out in Objective 3. And so that's what I'm thinking about as I'm solving this type of problem. I need to get all the bases to look alike. That's the first step before I can cancel them out. I need to get them all in a common base format. So that's where I'm going to go back to my common base chart, all right, in order to do step 1. I'm going to look for numbers of 243 and 9. 9 exists twice. So I'm going to find a column that has the number 243 in it and the number 9 in it. And if you notice, I already kind of wrote in red here. I see a 243 right there, which means that that base, it falls in the base of 3, the column of 3. Those are bases. And I also see a 9 right here. And so it just so happens that it falls in the same base, all right? The common base of 243 and 9 is 3. So I'm going to rewrite 243 in its common base format of 3 to the 5th. And I'm going to rewrite 9 in its common base format of 3 squared. All right, it means the same thing, but I need to go to this format here so that each piece of my equation will have the same base. So if I do that, 243 becomes 3 to the 5th. All right? And if you notice, this will happen sometimes. 243 already had an exponent there. And so whenever I have an exponent or two numbers next to each other, I have to multiply them. So I'm going to put negative 3k in parentheses, and that's going to tell me that I'm actually going to have to multiply those two things together eventually. Then I'm going to put times, because of the times right here. And this 9 is going to be rewritten as 3, if you remember from the common base chart, 3 squared. And that has a k there, and so in that case I can just do the math. 2 times k will be 2k. Alright? And then this 9 is rewritten as, and I'm going to put in equals because my equals sign right there. That 9 is also rewritten as the common base of 3 to the power of 2. And in this case, it's being multiplied with the exponent of k minus 3. So, I have done step 1 correctly. I have rewritten each base of the equation in a common base format. In this case, the common base of 243 and 9 was 3. 243 was rewritten as 3 to the 5th. 9 was rewritten as 3 squared. So I am done. Now, the whole point of doing that is that in step 2, I can cancel out all of the bases now because they are the same. This base of 3 goes away, that base of 3 goes away, and that base of 3 goes away, and then I'm going to drop the exponents down. So I'm done with step 2. And I did these numbers out of order. Step 3, it should say. Step 2 says to drop down the exponents, but before I do that, I need to talk about step 3, not step 4. This step right here. Remember, this is technically that base of 3 that I just canceled out is being multiplied with that base of 3 there. Whenever you multiply bases, base times base, you add the exponents, all right? So when I drop these down, I'm going to put plus, and then because this base of 3 that I canceled out was being multiplied with this base of 3, and that the exponent rule, base times base, you add the exponents. So that exponent becomes 5 times negative 3k, and I'm plussing now. It was base times base, but the bases are gone, and whenever you multiply bases again, you add the exponents. So I'm going to add this exponent of 2k. And that equals then, there's no multiplication happening on the right-hand side, and so I just drop down the exponent of 2 times k minus 3. So at this point, I have done step 2. I've dropped the exponents down, but I've also done step that's supposed to say 4 and that, or 3, and that's supposed to say 4. I've done step 3 as well. I remembered that base times base, you add the exponents. That's why I put plus 2k there. Now, step 4 is just distribute if necessary, multiply pieces together if necessary, and solve for the variable. And so in that case, it's going to be 5 times negative 3k, which is negative 15k, plus 2k equals, I'm going to distribute this 2 into that parenthesis. So 2 times k is 2k, and then 2 times negative 3 is negative 6. Now I just solve for k. I can combine like terms on the left-hand side. So I get negative 13k equals 2k minus 6. The k's are on the left-hand side, and so I'm going to move all of them over there. I'm sorry, the numbers are on the right-hand side, so I'm going to move letters on the left-hand side. I'm going to subtract 2k from both sides, so I get negative 15k equals negative 6. And then I divide by negative 15, divide by negative 15. Negative 6 divided by negative 15 becomes a positive 2/5. So k equals 2/5. And that is how I solve exponential equations. Go ahead and pause the video and try number 2 on your own, taking it step by step. So the first step is you're going to look for common bases. You should have paused the video and tried number 2 on your own. I showed you steps 1, 2, and 4. I put step 3 kind of in the middle of all that. Step 1, I found the common base of the bases 64, 1/16, and 1 to be 4. 4 raised to the third is 64, so I rewrote 64 as 4 raised to the third. And I had to multiply 3 with that 3b that already existed up there. Then 1/16 can be rewritten as 4 raised to the negative 2, and I multiply that negative 2 with that 2b, and I wrote that there. And then 4 raised to the 0 is 1. So my common bases are 4. Step 2, I can cancel out common bases, and I'm left with 3b. And again, please remember that it's plus. All right, base times base. This base of 4 times that base of 4. You add the exponents. So 3b plus a negative 3 times 3b plus a negative 2 times 2b equals 0. And then I just did the math in step 4. I got a 5b equals 0, divide both sides by 5, so b equals 0. Please check your work with mine, and if it doesn't line up with what I have there, please raise your hand and I will come look it over. Thank you for watching.